So we know that we can only add or subtract rational expressions if they have the same denominator. And so we have to be able to deal with situations where they do not have the same denominator. And that's where we're going to need to be able to find the least common denominator and then form equivalent rational expressions. So let's go back to ways to say 1, and we have talked about this before. When we have a fraction, if the numerator is the same as the denominator, we know that it is equal to 1. And of course, the same holds true when we deal with rational expressions. So x over x also equals 1. And I can put any polynomial over the same polynomial. And since the numerator and denominator are the same, this equals 1. Now, we know that whenever we multiply an expression by 1, the result is equivalent. And it may look different, but the value is the same. So, for example, if I take 1/2 and I multiply both the numerator and the denominator by 5, so I'm really multiplying 1/2 by 1, the result is 5/10. And of course, 5/10 is the same as 1/2 value-wise. Similarly, if I took 1/2 and multiplied the numerator and denominator by 100, the result would be an equivalent fraction, but it would look different. And basically, the value is the same. Now, 1 out of 2 is a little different than 100 out of 200, but value-wise, it's exactly the same. So, since we cannot add or subtract fractions or rational expressions with unlike denominators, we must find a way or we must find equivalent expressions with like denominators. Then we can add them or subtract them. So let's take a couple of simple fractions. Let's take 1/2 plus 1/4. And I'd like to add them, and obviously I don't have the same denominator. And now we're going to multiply the numerator and denominator of 1/2 by 2. So let's multiply by 2 over 2. And obviously we're just multiplying by 1. And the result we get is 2/4 plus 1/4. And now that we have the same denominator, we can add them and we get 3/4. Now let's take a look at this again. And this time we're going to take 1/2 plus 1/4. And we're going to multiply the numerator and denominator of 1/2 by 4. And the numerator and denominator of 1/4 by 2. So I'm multiplying 1/2 by 1, so the result will be equivalent, and I get 4/8. And I'm going to multiply here, and I get 2/8. And of course, we just multiplied by 1, so the result is equivalent. So now I have a common denominator. I can add them, and I get 6/8. And that simplifies to be 3/4. A lot of students will do this. They'll find their LCD by multiplying. In essence, they take the one denominator and multiply it by the numerator and denominator of the one fraction, and then take the other denominator and multiply it by the numerator and denominator of that fraction. And that's how they find their common denominator. You'll always find a common denominator that way. The problem you run into is it gets very big. And then you run into problems where you can't simplify. Now, numerically, I don't like that either because it becomes more difficult to simplify. This particular example was easy, but if we had nasty numbers, it would be hard to simplify. When you get into algebra, you'll get things that you can't simplify. So you really can't do this. You have to make sure that you find the smallest possible denominator, and that's what we call the least common denominator, which I'll always call the LCD, because I don't like to write a lot. So there are actually, if I can find my pen here, there are an infinite number of possible common denominators. But we want the smallest. So suppose I had 5/12 plus 2/15. Of course, we can't add these because they don't have the same denominator. So we want to find the least common denominator. One method of doing that is to make a little chart. And of course, 1 times 12 and 15 is 12 and 15. Now we're going to double them. So we get 30 and 24. And now we're going to triple them. And we get 45 and we get 36. And now we're going to multiply them by 4. And we get 60 and 48. And now we're going to multiply them by 5. And we get 75 and we get 60. And we keep doing that until we find numbers that match. We found a match. That's the smallest number that both 12 and 15 divide evenly into. Now let's take another approach. 12 equals, and we'll pick any two numbers that multiply to be 12. So how about 3 times 4? Well, 4 is really 2 times 2, so we could say that that's the same as 3 times 2 times 2. Any number that contains these factors will contain 12. Now let's take a look at 15. Well, 15 is 3 times 5. So any number that contains the factors 3 and 5 has to contain 15 as a factor. And that's what we're looking for. We're looking for a number that 12 and 15 both divide into. So if I want 12 to go into this number that I'm looking for, I know I need these prime factors, 3 times 2 times 2. But if I want 15 to go in, I know I need 3 and 5 as factors. I already have 3. I'm missing the 5. Let's take a look at this. This number contains 12, because here's 12. In fact, this number is 5 times 12. But this number also contains 15, because this number is 15 times the rest of this, which is 4. And of course, this number is 60. So what we did was we took all the factors and we built an LCD. That's what we're going to do in algebra. So again, we have to factor.